us today for our 2021 Beyond Big Data virtual event. If you have questions at any time, please feel free to send a message using the chat feature and we will address them during the Q&A at the end. We're going to jump right into breakout number 1, part 1, Rise of the Data Cloud. And I'm so pleased to welcome our presenter for this session, Kent Graziano, Chief Technical Evangelist from Snowflake. Kent, thanks for being here with us this morning on our third day of Beyond Big Data. The virtual stage is all yours.
Well, thank you very much, Allison. I'm happy to be here and welcome everyone for our event this morning. I'm glad you're able to be here for my little talk about the data cloud. So I'm Kent Graziano. I'm the Chief Technical Evangelist at Snowflake. Been with the company for a little over 5 years now, and it's just been a very exciting time, and really happy to be able to talk to all of you about Snowflake. The database world has changed, and the data world has just changed so much in the last bunch of years. Right now, Gartner's predicting 75% of all databases are going to be in the cloud by 2022, and that's barely 9 months away. So to say, the future's here and the future is in the cloud is probably an understatement. IDC did a study recently, and they predicted that we're going to have over 175 zettabytes of data by 2025. And over the years, I've seen this number just grow dramatically. We've got data coming from all over the place now. I mean, it's no longer just your ERP systems and your back office systems that are providing data. We're getting data from mobile devices in particular. It's just exploded, the amount of data coming from there. And of course, IoT, smart devices, smart meters, smart refrigerators, smart everything, generating all of this data. And now we've more or less, we've gotten over the curve of being able to manage all this data thanks to the innovations during the Hadoop era, that we figured out, there are ways to store all this data cheaply. The challenge now is not just, how do we manage all this data? It's really how do we take full advantage of that data and make it easier to build and manage and govern all of this data, to do the analytics and do the machine learning and apply artificial intelligence as we really want to for business value. The concept of data as an asset is not really new, but up till now, it's been pretty difficult to really make it a reality. Changes in the technology have really changed the way that we're working with data these days, making it easier for us to turn it into actionable assets for the business. Now, of course, at the top of the list is the rise of the cloud itself, because unlike the traditional platforms that we had to deal with, they were basically just boxes with fixed, limited resources. The cloud offers us the ability to have near unlimited capacity on how we store the data, but also how we process the data. And this is giving us the opportunity to run huge numbers of workloads at very high performance in a centralized platform that's more easily provisioned. Next, we've got the explosion of data that I just talked about, and it's going to continue to grow in both the size and the variety of data as all sorts of new devices come online. And we talk about edge and IoT and all these different things that are happening that are generating all this data. But within all of this data, there lies a real treasure trove of insight if we're able to tap into it. And the last change really is the diversification and the democratization of analytics. I mean, arguably everyone today is an analyst of some sort, or a data storyteller, or even a citizen data scientist. And as a result, when, where, and how we do analytics has completely been transformed, especially from the very beginnings of my career to now. And it's really being pushed into pretty much every corner of an enterprise, and analytics is really kind of becoming a central part of how every person works with data. The key to success in data science is being able to obtain, manage, and process large amounts of data, right? Many organizations are still struggling with this, even for their legacy BI and reporting systems. So how can we ever expect them to handle 1,000 times more data from hundreds of sources coming in nearly every second in real time and near real time? How are you going to do that in order to make our data science and machine learning models more accurate and take advantage of all of this? And most companies find that their data scientists spend somewhere between 20 and 30% or sometimes more of their time searching for, getting access to, and exploring data that's spread across the source systems, their data lakes, their data warehouses, their data marts, wherever the data is. And those teams then have to spend another 40 to 50% of their time cleaning and processing the raw data, then conducting feature engineering to derive the new types of data that can be used in model training. And this combined means that about 80% of a data scientist's time is spent wrangling data and not actually building and training models. When they do finally begin to build and train the models, they find most of the tools offered by some of the larger cloud vendors are outdated or require proprietary data formats and are really optimized to deal with data stored in their specific ecosystem. So in order to become more efficient with data science teams, we really need a modern data platform. And, let's face it, today, still, companies are falling short of realizing this sort of potential because of data silos. And even with the rise of all the application clouds like Salesforce and Workday and the infrastructure clouds on AWS, Azure, and Google, the amount of data we have to drive the business has exploded, as I've said already. But that data is now spread across different silos and environments, even in the cloud. So many companies are still not able to connect the dots in real time because of these silos. And this can lead to poor customer experiences, bad decisions, and even lost revenue. And on top of it, the silos are expensive and time consuming to extract all that data from and apply governance and collaboration as we're working with many different technologies. So we believe that one of the ways to solve that problem is with the data cloud. And you can really achieve the vision of eliminating all these silos today with the Snowflake data cloud, where thousands of organizations are already unifying their siloed data in a global, secured, and governed platform, providing them innovative ways to unlock entirely new business opportunities. The data cloud is actually giving organizations access to their data in near unlimited scale, concurrency, and performance. And it's about removing the barriers between you and the data so that you can do your jobs. It allows you to find and derive value from even a rapidly growing catalog of governed data sets and services, still in a very secure and compliant way. And the data cloud removes the barriers that are preventing you from quickly and securely accessing all of the data you need to drive your businesses with. Wherever the data or users live, we can deliver a single and seamless experience across multiple public clouds, eliminating all the previous silos. Now, to be clear, the data cloud is made up of two components: the technology, which is Snowflake's platform, and of course the data, the actual content that populates it, so that you can do all of these different things and drive business outcomes. Because really, if you don't have the data, then what's the point? We really can't do what we're trying to do. Now, Snowflake's innovative platform is the engine that actually powers the data cloud. It's a technology that provides the storage, compute, and services that organizations need to operate in the data cloud. And Snowflake is the only platform built from the ground up exclusively for the cloud and delivered as a service. It's a single platform that enables secure and governed access to all your data, so you can eliminate the data silos and support many different workloads. It's available on all three major clouds and can support everything from data warehousing to data lakes to data science in a single environment. And this will allow you to deliver as much data as you need to as many data consumers as needed. And this really is enabling the vision of data democratization. Being able to get the right data to the right people at the right time. With the Snowflake platform, data scientists are able to accelerate the velocity of their model development, by gaining significant efficiencies in the way they access, process, and consume data. So taking that 80% time and dropping it down to more like 20%, and really greatly reducing the time needed for all the prepping and wrangling of the data so that you do have more time to improve that work with developing your various models. Now, from a performance perspective, this is a great quote from one of our customers at Devon Energy, able to run 2,000 simultaneous queries against a 40 billion row table and have all 2,000 queries return in under 10 seconds. That's an amazing amount of power that we just haven't had available before. But it does, to many people seems like it's a little too good to be true. So, how is this possible? Well, it's all about the architecture. And that's what got my attention when I first was introduced to Snowflake. What makes us unique is a groundbreaking patented new architecture called the multi-cluster shared data architecture. We've separated compute from storage, so Snowflake allows you to spin up and down on-demand independent compute clusters to power all your loads and queries without any contention. When the job's done, the virtual nodes can automatically be turned off, saving you costs. The platform is ANSI SQL, ACID compliant, and it's fully secured with end-to-end AES 256-bit encryption, and all of that's managed for you via our cloud services layer. There's nothing for you to do. It's just all built in. And the system is totally new code. It's not a revision of some other code base. Our founders actually started from scratch so they could build a system to take advantage of the elasticity of the cloud. Now, one of the really cool features that this enables with the separation of compute from storage is zero copy cloning, something I wish I'd had decades ago when I was trying to build out large dev and QA environments in particular. And so we solved this with the zero copy cloning, where you can have a full-size copy of your production data to do testing on. And this is used by many data science teams to build sandboxes on the fly and really simplify their DevOps process for getting access to data. Because the reality is, prior to this, no one ever really got enough storage to do real dev and QA testing on a full load of data. But with Snowflake, there is no duplication of the data. It's all done under the covers via metadata pointers to immutable files that underlie our database system. It makes it very fast. You can typically less than a minute, excuse me, for a terabyte of data to be cloned so that you can now access it, use it, and even write back to it without impacting the original source of the data. It's very easy to do. We have very simple SQL, a clone clause in a create table, and you can do it at a database level. You create a database this way, an entire schema, so you can replicate any of these with our zero copy cloning with a very simple statement. And we even have a feature called time travel, which allows you to clone that data at a point in time prior to now. So if you have made a mistake in loading up some bad data, you can recover from that very quickly by simply cloning the database 1 second prior to the execution of the offending statement. And you're back to that. No going and getting backup tapes, no having to restore from anywhere. You just simply do the clone at that point in time, and you're back in business. Big data, weblogs, IoT, I mentioned all of that before. Traditional databases have a very hard time dealing with semi-structured data like JSON and XML and Parquet. Well, we invented a new data type called variant. So now you have this type of data side by side with your more traditional structured data. It's simply another column in a table with this data type. And you can load and query the data with no ETL required. You don't have to parse it out. You don't have to break it out. You simply load it in as is, say, an entire JSON document, and you can write queries against it using simple extensions to SQL. So you do not have to have all these additional technologies in order to wrangle your data. Now, Snowflake's secure data sharing capability is what really makes the data cloud unique. Accessing the data is completely frictionless. There's no copying or moving of the data. Customers can designate data for sharing with external partners and just grant them permissions to access it, and it looks like a read-only database to them. The recipient consumer can now explore the data and query against it and join it to their own data. And that means you can always have the freshest data with zero latency, in that whenever the data provider updates the data set, you immediately can see that. And this is a great way to really minimize the amount of moving parts so you can get more value from the data faster. There's really three offerings within Snowflake that allow you to collaborate on data like this. And you can choose different ways for different use cases. So the simplest form we have is a direct share, which is the ability that Snowflake gives you to easily share data with another company or really another Snowflake account. So the data just shows up in their account as a read-only database. And this is really based on the underlying technology that I just mentioned, which is called secure data sharing. For sharing at scale, you can create your own data exchange so that you can share data with your entire business ecosystem, suppliers, partners, vendors, other customers, as well as other business units within your company that may be using a different Snowflake account. And this is an invite-only option, so like a private app store. So you're in complete control of who can see the data. And finally, we have the Snowflake Data Marketplace, which all Snowflake customers have access to. It allows you to discover and access a variety of third-party data very easily with a couple of clicks. They sign up and then have access to it, and it becomes immediately available to you. So what are organizations doing today with Snowflake? Well, the data cloud isn't just marketing jargon. We've got thousands of organizations already sharing data with their business ecosystem using the data cloud. And in this visualization, which is actually a report that our team has built, it shows you every customer that is in Snowflake. Every dot is a customer. And the lines between those dots is where they're sharing data and connections. The big cluster there, labeled COVID-19, is where companies are pulling COVID-19 testing and vaccine data from the Snowflake Data Marketplace to augment their analytics. And many of those customers are using this data to manage regional impacts of COVID on their business, as well as forecast business recovery. On the perimeter, you see a lot of other companies who are just sharing data directly one-on-one with their partners and suppliers. So there's really a lot going on already today in the data cloud. You know, the world has come together to fight COVID-19, and it's also created a certain amount of uncertainty and risk all over the world. So the conditions are changing on a daily basis, especially now with vaccines, and everyone from companies to governments are looking for data to get insights on how their organizations and communities can be impacted. And one of the ways that we've been helping support that is that this COVID data is all available for free on our Snowflake Data Marketplace. Now, the data clouds are causing companies to view their entire partner and data ecosystems differently. Goldman Sachs is building their own data exchange to drive their investment decisions by combining internal data sources with data from external vendors like Standards & Poor's, Refinitiv, Morningstar, and FactSet. And this is allowing Goldman to drive secure collaboration across all their data and ensure that all the data is discoverable, accessible, and secure, and fully controlled. And imagine how much time you could save if all you had to do to access a pre-cleansed data set was to click a few buttons. You know, a great example of ROI for a machine learning use case is Harmony in Australia. They do microloans. And their key issue is predicting loan performance. So they need to predict the likelihood of a loan default, predict whether a customer is a good or a bad risk, and offer the correct rate. And what they said with the implementation of Data Robot in conjunction with Snowflake, they're able to get some massive improvements. In a 1% improvement in what they're able to do with their models can equal as much as $1 million a year for them. So this really has a major economic impact. Another example is Instacart, which many of us, I think, have come to know over the last year. They needed near real-time inventory so people don't order food that's not there. They're dealing with predicting the validity and availability of 500 million items and need to do that every 30 minutes. And that turns out to be 130 features and tens of terabytes of data processed. Using Snowflake for their scoring architecture, they're able to score 40 times more items in 20% of the time, and using 1/5 of the resources that was required to do all of this in their old architecture. These stories are just a few that indicate really how profound the effect of the data cloud is going to be on different industries over the next few years. And really, we're just getting started. And we're going to see traditional industries like manufacturing and agriculture and education emerge from digital transformations and introduce a new wealth of data into the data cloud. We'll also see new ecosystems developing as data is combined and applied in innovative ways. Organizations that embrace the data cloud are going to be rewarded with new opportunities, and they're going to find new ways to enhance their customer and stakeholder value, develop lasting and stronger partnership with their peers, and solve some of the toughest business challenges out there, and really become data leaders. And the Snowflake data cloud is going to continue to grow and evolve as more and more organizations move their previously siloed data to it. Effective use of data is one of the most critical drivers for organizational success today. Now with the data cloud, the barriers and friction that have hindered your organizations from democratizing all that data are all but eliminated. So you too can be part of this and part of this revolution with data, and really become a data leader and take full advantage of your data assets. Thank you very much. And I think now I can, ready to take a few questions, if there are some out there.
Thank you, Kent. And I did put some reminders in the chat for everyone to ask your questions there if you have anything. While we are waiting for any questions to roll in, I'll remind you to head over to our tech showcase after this from 11 to 12 and join us for business as usual at noon. The link's available in Sched today. Any questions for Kent?
Quiet audience this morning.
Presentation had all the information you needed in it. That's what I'm thinking.
Apparently.
Oh, we just got one in from Bish. It says, how is Snowflake different from a service offered by AWS like Redshift?
The architecture is completely different, and it is all basically managed for you. There's no distribution keys to define. You simply load the data and query the data. And because of that separation of compute from storage, you can spin up multiple independent compute clusters to drive your different workloads. So you can have, 2 nodes running your ETL process, and maybe you need a 4 or an 8 node to run a larger machine learning process. And you can separate all this out, working against the same data set, so you don't have that contention. So you can fire off a massive machine learning algorithm that's processing billions and billions of rows, or even trillions of rows in some of our customers' cases, and not impact anybody else on the system, because the compute is able to be completely segregated. And that's not something you can easily do in any of the other platforms. That's, like I said, we patented this multi-cluster shared data architecture. It's a completely new approach to separating the compute out, so you have that finite control, and you really treat it as a utility service. We charge per second per node, and we have auto suspend, as I mentioned, so that when the process is done, it automatically turns itself off. So you aren't having to pay for compute that you're not using.
Excellent. Thank you, Kent. And thank you for asking a question to our chat room.